Hi, welcome back to Mathematical Maths, and today we're going to go over different things about integration, very basics, and how it actually relates to what a derivative is and different things about it. So let's get started. So first of all, we can say what is the point of integration? It's to basically find the area underneath the curve. And how we're going to do this, well, I'll show you. So when we take the derivative of something, for example, x squared, we subtract 1 from the power, or we bring the power down, then we subtract by 1. Okay, so this is going to be 2x. And the way we can represent this is n, where this is the n. So this is our function, and how we take the derivative is we bring the n down in front, multiply it by the a, and the x to the power of n minus 1. So that's how we do the derivative. Now, you may be thinking, well, we know what a derivative is, but how does that relate to integration? Well, integration is the reverse of the derivative, or sometimes called the antiderivative. And the way we can prove this is, imagine if we had the function y equals x squared. How would we get the area underneath that? Well, first of all, apart from integration, we see that this is a triangle. And for triangles, we can say it's equal to 1/2 base times height. Now, we know that we'll call this point here the x location. So we're going to put x in for the base. So 1/2 multiplied by x, multiply. Now we have to get the y location for the height. And we can't just put in y and then mix the x and y. So we can say, well, y equals 2x. So multiply that by 2x, and that's the height. Now, if we simplify this, the 2's cancel out, and we're just left with x squared. But isn't that this function? It is. So that shows you that these two functions are related by what's known as integration. So, and that's the exact opposite of what we've done to get the derivative. So if we do take the derivative of this, we get to this. And if we take the integral of this, and it's called integration, we go from here to here, and that's the antiderivative. Now, I'll show you some examples of how this works. So, let's say we have the function x squared, okay? When we differentiate it, what we're going to do is bring the 2 down and then multiply it by x. Or bring the 2 down and then subtract the power by 1. And if we were to show this in steps, step 1 would be bring the power down. Bring power down. Okay? Then what we have to do is subtract 1 from the power. So step 2, sub 1 from power. Okay? So for integration, since it's called the antiderivative, we just work backwards. So to go from here to here, step 1, instead, so because we're working backward, instead of going 1, 2, we're going 2, 1. So we're first going to add 1 from the power, because that's the opposite. So add 1 to power. And the second step, well, what's the opposite of multiplication? Multiplication, division. So then subtract. Divide power. Okay? Now, how we can represent this is we've had this function here to represent the derivative. Now, if we want to represent integration, if we have a function like a to the x to the power of n, well, first of all, what's the first step? Add 1 to the power. So we're going to add 1 to the power. Then what we're going to do is divide by that power. So n plus 1, we're going to divide n plus 1. And that's how you represent an integral. So some examples of this is just like the x to x. So we have 2x. X is to the power of 1, so we add 1. That's 2. Then we divide by 2, and we get x squared. And that's this function here. So that is how we can get the integral, or the area underneath the curve. Now, this is the symbol for an integral. It's the integral sign, and basically it means to do this process. Now sometimes when we're integrating, you'll get values maybe here and here, so maybe like 5 and 3. And what this means is you want to plug in those two values into the function we've made. So if they give us, tell us we want to know the area between 0.5 and 0.3, well, we're going to integrate between here and here. Now you may be asking how to do that, and I'll show you. I'll be back in 1 second. So we're going to continue on with the integration, and just to make sure you've understood what's happened so far, we're going to go over the differentiation and integration. So with the differentiation, you subtract 1 from the power, or you bring the power to the front and then you subtract by 1. And this can be seen in this example. 2 to the front, 2x. Then we subtract 2 by 1, that's 2x. Because we had the exponential value 2, subtract by 1, that's just 1. And 2 multiplied by x to the power of 1 is the same as 2x. Now what happens is, with the integration, it's just the opposite. So here we brought the power down, then subtracted 1 from the power. But in the opposite, we're going to add 1 to the power and divide by the power. So here, we have 2, add 1 to the power, that's 3. Then we divide by 3, and we get 3 over 3, which is just 1. And this can be represented like this. Now, last time I said that when you're taking the integral, and this is the integration symbol, and there's sometimes 2 points here, and these 2 points shows the range which we're integrating from. So if you have a function like this, and you wanted to find the area under these 2 points, this is how you'd represent that, from point 5, x equals 5, to point x equals 3. So that is how you get this area here. Now, when we take the integral, let's say we're integrating the equation y equals x squared. So how we do this is we would say we want to take the integral, which is this symbol here, from 0.5 to 0.3. So this is how we're going to do it. And then we write the function here, then we put dx, and that's to show that we're doing it with in relation to x. So what we're going to do is we're first going to integrate this, and we add 1 to the power, so that's 3, x to the third, then we divide by 3. So this is our integral. Now what we can do here is we have to draw a line, and we're going to say 5 and 3. And this is to show that we've integrated it, and then we still need to go between the points 5 and 3. So what we're going to do now is, if we integrate and just put 5 into the x, we're going to get everything from 0.5 to 0. But because we want to get from things in that range, we're going to go things in 0.5 subtracted by things in 0.3. That'll just give us that area in here. So what we're going to do is we're going to put in 5, and that's going to be 125 divided by 3, and then subtracted by whatever we put into 3, and that's going to be 27 over 3. And that simplifies to 40, 4, 5, that's going to be 1.2, that's 6, 2, 6, 6, 6, 6, 6. Non-divisible, anyway. And then that's going to be minus 9. So if we do this now, we'll get our value. And this is how we're going to do the integration. So we're going to put in a few more examples, but for now, if you have any, like you're unsure about anything, just go back to the beginning of the video and rewatch it.